Welcome to February's Leetcode Challenge. Today's problem is broken calculator. On a broken calculator that has a number showing on its display, we can perform two operations. Double, multiply the number on the display by 2, decrement, subtract 1 from the number on the display. Initially, the calculator is displaying the number x, return the minimum number of operations needed to display the number y. So initially, this sounds like a very simple problem. All we have to do is have a while loop and say while x is less than y, or rather while x is not equal to y. If it's less than y, then double it, and if it's greater than y, then minus 1. And we could simply write an algorithm like while x does not equal y. If x is less than y, then we double it, else we subtract 1. Something like that, right? And we'll keep track of number of steps by saying steps plus equals 1, something like that, and return steps. Now this would work for certain certain test cases like this one, but say that we had one like 5 and 8. What would happen then? Well, this actually wouldn't work. My algorithm would return 3, but the expected answer is 2. The reason for that is my algorithm will multiply this by 2, making it 10, and then subtract 1 and then 1 again. So like 10, 9, 8. So that's 3 steps. But it's better actually to subtract 1, make it a 4, and then multiply by 2, which would be 2 steps. So this algorithm would not work. How could we improve it? Well, the problem is the path that we can take to get there. If I used this would always take this weird path where it would double and then subtract. What if it'd be much more, see the other path going, subtracting and then multiplying by 2, the way we need to figure that out is actually to go backwards. If we start at the y and try to figure out, is it better to, well, okay, there's two things. If we start at the y, if it's odd, we would have to add 1 to it and then divide it by 2. And that's 2 steps. If the y is less than x, then we don't really have much of a choice. We only have the option of adding or decrementing this by 1, right? And if we just go backwards, this algorithm actually can work. We wouldn't need to do anything recursively. We wouldn't have to like figure out what all the paths are. We can mathematically prove that always it would be better to plus 1 and divide it by 2 rather than minusing 1 all the way back down to whatever the x is. Okay, so if we did this, the algorithm would still be something like this, but we had to simplify a little bit. First thing is say if y is less than x. Well, if that's the case, then there's only one thing we can do. We can only decrement the x, right? So we don't even need to go through loops with that. We can just say steps plus equal. It would be x minus y, and that would be it. Then just make the x equal to y to get out of the loop. Now otherwise, if if y is greater than x, then we need to figure out, is it odd or even? So if y is even, then simply divide it by 2. Otherwise, if it's not, well, then we would need to actually add 1 to it so that on the next loop we can divide it by 2. And each time we do that, we have to add 1 step. So this would actually work. We're kind of just going backwards here. Now let's just see if this works. Yeah, and there we go. So that would be, in terms of time complexity, it's not quite O of n. There's some sort of log involved in here. Not sure. Log n? Something like that. Yeah, okay, I'm just going to end it here. Yeah, you can definitely simplify this algorithm a little bit with some tricks and stuff, but this is more understandable. So I'm just going to keep that. Yeah, so thanks for watching my channel. And remember, do not trust me. I know nothing.